Thank you, Jim. Good morning. And actually, yeah, the caffeine this morning is slow to kick in, I must admit. So, thank you for the invitation. I'm really pleased to be part of this exciting symposium and day. I've already learned a great deal, and this is quite exciting new technologies, and I look forward to. I'm not sure about the dry cheese, and you have to combine that with wine somehow, and what, you dip it into the wine, or I don't know. This is really exciting. I'm just kidding, of course, but yeah, I'm gonna talk about some new approaches, and in your presentation, Jim, you presented things from 10 to 20 years and 20 years beyond, and improbable things to happen. But what I'm going to be discussing this morning is all happening right now. We can do that, and I think we should do that as much as we can to enhance our ability to understanding how people eat, why they eat, and how we can intervene to change that behaviors. So this is my disclosure slide, current funding and implications. Yeah, we talked about those two books, which I actually don't make money out of. So it's interesting to write a book because you do a lot of research and so on, and then you don't sell so many, so you worry. So this is an exciting time because we have so much data available now to show and to prove the role of nutrition on health, and this was published in April, just recently. This is the Global Disease Burden Analyses, and they show that diet is responsible for, that's the most important risk factor for non-communicable disease. And out of 195 countries, 11 million deaths, 255 millions disability adjusted life years. Those three risk factors are the most important ones. Not enough fruit consumption, not enough whole grains, and not enough nuts and seeds. And this is by different countries. And the key to these data actually is to have data. And the words on the left side there you probably can't see, but these are different areas around the globe, and they can relate the consumption of fruits or nuts or whole grains to disease outcome. And we're actually very poorly represented in Canada on these graphs, and actually even in North America, what they do is they use, for example, the cohort study, the nurses' health study, to derive some of these data. And so I guess one of the key points is that in Canada we don't have such a good grasp on what's happening in terms of our population. We have surveys that happen once in a while in Canada, but we now have the capacity to do much more than that because of technology. But the key here is to measure, it's to have a measurement. And so we have these new capacities in terms of for example, web-based tools that can assess dietary intake in populations. And traditionally, in population-based studies, people have used food frequency questionnaires, which is quite easy to set up, even from a web-based perspective. To do that with a 24-hour recall is a little more complex because people are self-selecting foods that they consume and so on. So it's more challenging. And in recent years, we've seen a few of those web-based 24-hour recalls, like for example, the ASA 24, which was one of the first ones developed by the National Cancer Institute in the US. And this one was recently adapted for Canada in both French and English. But we've gone our own way in developing such a web-based tool, a 24-hour recall that can be used on the web and to therefore track and measure the dietary habits of the population and almost in real time. And this is quite a challenge to do actually because of course people, and this is pretty small, but this is the actual interface that people use when they are invited to complete these web-based 24-hour recalls. They have to select the foods according to each meal at different time points and so on. So this is very hard to set up, but once you have it, it's very, very productive. And of course, it works similarly to any other kind of survey where people self-select. They identify the food, self-select the portion size, the amount, the number of servings they've used and so on. And you can do that for each meal, and then you can track different measurements for your population that you're actually measuring. So for example, in our interface, we can, we've built several reports that can allow us to extract the data in different ways. For example, we can have a table of nutrient intake in a population once everyone has completed the survey. The number of servings of the old Canada's Food Guide, we're just revising it according to the new ones. You have the context of the meals, because people, every time they enter a meal, they say, well, this is what I ate at breakfast at that time, at dinner, at lunch, and so on. So this is very, very efficient, because the data, once people press submit and they finish completing the web-based 24-hour recall, you have the data at hand. And there's no additional need for analyses, for interpretation, and so on. So you can actually be very efficient in looking at your data. And this is an example. This is, again, very small, and the intent is not for you to read this, but you can extract the data and have information on the time of the meal consumption, were they at home, were they at work, were they alone with somebody else, were they looking at a screen when they were eating, and so on. And then on top of that, everything else that nutrition related, how much calories, how much nutrients, and so on and so forth. So this is extremely efficient, and that allows us now to contemplate the idea of running large base population studies, which will allow us to get data on our population, and not just a survey that we have once in a while, but a survey that we are conducting every year or every second year to see what the changes are in the population. So we've pilot tested this tool in Quebec towards a big study, which is called Nutri-Québec, which will be a population-based study of the Quebec population. And the intent of Nutri-Québec is actually to, and it's starting, we just got ethics approval yesterday, so we're just going to start very soon. But it's really to first track the population dietary intake over time. So we're gonna follow the same population for several years. This is similar to what we have for example, Nurses Health Study. But it's really a population-based study, so we're trying to get as close as possible to representation of the population. We'll do that through statistics and so on, but basically the main objective of Nutri-Québec is to assess the impact of policy on food policy on dietary habits of Quebec adult population. So we're partnering with the Ministry of Health for that, and we have of course, our intent is to measure the impact of the policy, but also it becomes a population-based cohort which we can use to do research and so on. So we've pilot tested that, and using 5 main areas in Quebec, we've tested 1,000 people which were representative for age and sex of these 5 regions, using these web-based tools, just to see how this can be done and how this works. And this work was published by one of my students who's here, Didier Brassard, in the Canadian Journal of Cardiology just recently. And as soon as people have completed the survey, you can get data like this very quickly. What's the sodium intake of the population? 80% of the Quebec adult population consumes more than 2,300 milligrams of sodium per day, which is a lot. A big challenge there. Saturated fat, same thing, too much consumption. So, but the thing here is, once we have the data, it's very, very simple to have all this analyzed and interpreted very quickly. The healthy eating index, for example, 56 on a scale of 0 to 100, not very good, and that seems to be improving with time, over time compared to previous data in similar population. So instead of, and this was done using a cohort of 1,000 people, very efficiently in terms of cost and human resources, because once the people are once again, I'm repeating myself, but once people are completing these surveys, you have all of these data available. And what we're going to do in Nutri-Québec is to actually multiply this effort by thousands and hopefully have tens of thousands of people being followed up over time. This is a cross-sectional analysis. So, and again, Didier will be presenting some data here at the meeting, but we just were curious to see what's the difference between a web-based, of course the web-based tool was validated using feeding studies and markers in plasma and so on. But we were curious to see, is there a difference between a web-based approach and a classical approach using interview-based 24-hour recall questionnaires in terms of the data and the quality of the data we get. So what we've done is we used data from the CCHS 2015 survey. We took the Quebec population from that survey and compare the data to our data, which is a similar population for age and sex. And it's interesting, if you look at food groups, the number of servings is quite similar between the traditional CCHS 2015 data in terms of fruits and vegetables, whole grains, a little bit more servings per day using the web approach in a similar proportion. More dairy is reported when you use a web-based tool compared to a traditional approach. Again, these are data from a similar population in Quebec. But there are quite a lot of differences in terms of the amount of food that comes from other foods, which is a key group to address, because this is where most of our problems are in terms of diet in Canada. And so if you use a web-based approach, you have more calories compared to using the interview-based approach. And this is like a 25-28% difference between the two tools. Which one is right, we don't know actually, because there's no way to know which one is right. But certainly what it tells us is that there is a difference when we use web-based approach. And there are data suggesting that when you have a screen and you answer questions and behind your screen, you're less prone to social biases, desirability biases. So we tend to believe that there is perhaps some under-reporting with the traditional approach. And when you look at that from a really using classical approach to assess plausibility of intake, the web-based approach suggests 14% of under-reporting if you use different equations, compared to 25% using an interview-based approach. So this is another interesting advantage of using web-based beyond its efficiency. Web-based approaches also may help us get a better picture, a more correct picture of if we believe that this is the one that's correct, of course. So this is not an easy task to do, which one is correct or not, but we tend to believe, because there is data on that using web-based approach is kind of a good way to get away from underreporting due to social desirability. And so this becomes an important issue when we look at nutrients. For example, if we look at salt, if we look at saturated fat or sugar, and we know that there is a possibility of significant underreporting in the other foods group, when we look at the population intake of saturated fat, for example, from the CCHS 2015 data, and Stephanie will be talking about this on the poster we have here also. So the average in the population based on CCHS is 10.4% of calories, but we know we're missing probably 25% of calories from other foods. So this is probably an underestimation. And so based on a number like that, you would think that about 50% of Canadians consume too much saturated fat, but if you take into account the underreporting and the possibility of missing calories from other foods, that would be more towards 75% of people consuming too much saturated fat. So again, we have to keep that in mind using data from our survey, and as we move towards new approaches that may be more efficient and less prone to biases. Okay, so this is using our traditional approaches. This is now possible. This is not in the yellow or gray or whatever color. We can do that now. What we can do also right now is to be a little more technical and use the tools that we have in the lab to actually measure what people eat. And this is very preliminary data. And again, Didier, who's here, will be having a poster on this. But so what we did here was we used our series of feeding studies we've done over the years. In that case, we're looking at the effect of the Mediterranean diet on health, on cardiometabolic health, compared to a control diet, which was typical North American diet. The people were receiving all of their meals every day for 4 weeks to 5 weeks, and we were measuring the effect of diet on cardiometabolic risk factors. So we have this feeding trial, which are stored in the freezers, and we can go back to that and see, can we predict in a blind way if the participants, these are all studies where participants were in a crossover design, so were they on the control diet or were they on the med diet, just looking at their plasma metabolome. So we used a high throughput LC-MS approach where we can actually track 40,000 ions reflecting different metabolites that relate or not to diet. And to make a long story short, for example, if you take, I don't know if this works. Yeah, this is, looking at predicting whether you're on a control diet or on a med diet in men. And we can predict using these metabolites, using artificial intelligence, and just let the algorithm run and find out which are the best predictors of this status, whether you're in a med diet or control diet. And there are a number of hits that actually can predict with an accuracy of 99% on which diet you are. So using blood samples, we can now predict very, very closely and with very little error whether you're consuming a good diet or a bad diet. And this drives us away from self-report data. We could eventually, of course, this is not applicable right now to the whole population in clinical setting and so on, but as we go towards more development and increasing the capacity, we'll be able to do that in a clinical setting and actually just take a blood sample and, well, you're not eating well or you're eating well just based on what your sample looks like. So this is, of course, this is doable now. We can do that. It's not applicable to clinical practice or even to epidemiology right now, but we're moving towards that, and this is very promising in terms of how we can address the relationship between diet and health. How am I doing with time here? Yeah.
Is it permitted to ask a question about your last slide?
Sure. Mr. Chairman?
Well, I noticed walnuts intake was associated with testosterone. Is it a constituent of walnuts?
So these are the metabolites that were predicting that we used to increase the capacity to predict on which diet you were, and they are related somehow to food components. But we have to work more on this, and these are. These, for example, this molecule here is associated with legumes, but this is not 100% association, of course. So is the walnut? You're talking about a walnut. Where's the walnut? Here. This is, of course, a molecule that we have endogenously, but we have to work out these associations. Based on the literature, there was some link that were created between these two components. But this is thin ice, as you can see, so we have to work that a little more. But this is, I think, promising in terms of how we can predict on which diet you are. Just to go back to this relationship here, it's not directly related, but we had also in this design a weight loss component. So, for example, if you have men on the med diet and have them lose weight, 10% of their weight, because we were studying the combined impact of med diet and weight loss, then the metabolome of the diet could not predict whether you were on weight loss or not, because the effect of the diet is so strong that it becomes, then it's a 50-50 chance of saying you're on weight loss or you're not on weight loss when you're on the med diet. The med diet is so strong on your metabolome that you cannot discern then the effect of weight loss on top of that. So I understand I'm not really answering your question really well, but this needs to be worked out a little more in terms of understanding these prediction and associations. So what we're doing at Laval University, we've set up this a very huge initiative called Pulsar, which is a capacity to understand health, sustainable health, and using a very holistic approach. So we're basically using all the data that's available out there. Data on diet, of course, data on health, data on the environment, the built environment, the social environment, everything we can measure to try to predict outcomes, to try to predict disease, to measure the effect of intervention on health and so on. So this is a 150 investigator-based approach where we have social scientists, we have architects, we have engineers, we have health researchers and so on. So 150 of them coming together to use all the data that's available to try to understand the relationship between the environment, the behaviors, the policies, and health. So I'm not going to talk more about this, but just to give you an example of what we can do now using this approach. So this is a map of Montreal, and again, based on our pilot study, 1,000 individuals in the province of Quebec. We've measured BMI, and you can, of course, map out the BMI distribution in the population because people are geolocated as we do their measurements. So we know where they live, we know where they work, and we can actually then say, well, this is where people with obesity are on the Montreal map, and where the people without obesity are. And if you do a blood sample, you can do the same thing for the risk of diabetes, measuring insulin and glucose. So where are the hot spots for diabetes risk? Well, the red ones are where you would find higher risk of diabetes in the Montreal area, for example. And of course, these are preliminary data, so if you live in Montreal, don't start to worry. Yeah. But the idea here is to move towards a more, what we call precision public health. So we know about precision nutrition, precision medicine, but now we identify hotspots of areas where there are problems. And usually these areas where there are problems actually co-locate with low socioeconomic status areas also. But we can then try to disentangle the contribution of each risk factors to different problems. So if we go back to diet, this is the Quebec map. For those who are not too familiar, the Château Frontenac would be about here, and this is the bridge. So we can do the same with diet. So you can actually, using a web-based 24-hour recall, measure the diet of people, then put it on a map, and you have hotspots of areas where the diet is of very low quality and areas where the diet is of a higher quality. And again, there's a very strong relationship between the socioeconomic status of these areas. This is where the university is, the higher socioeconomic status neighborhoods. This is the lower socioeconomic status neighborhoods. So, but to do that, you need to measure. So we were able to do that because we've measured using the web-based 24-hour recall and then map out the quality of the diet of the people on the map. So some people are exposed to that every day. So it's very hard to eat well when this is your environment. So you can actually then use data and different equations to describe the food environment to which people are exposed. And so you have on the same map in Quebec, areas where the food supply is of low quality, and the other areas where the food supply is of higher quality. And there's not 100% relationship between diet quality and food supply quality, but of course if you're exposed to a lower quality food supply quality, then you're most likely to, it's going to be more difficult to eat well. So in a concept of precision public health in the area of nutrition, well, you would want to identify the people that don't eat so well in areas where the food supply is not of good quality. And then you would like to intervene in these areas to improve the food supply of these people so that you can have an impact on their food intake. And so what we're trying to do, and when we work with the Ministry of Health, for example, or our communities or cities, we can then try to implement interventions where we identify the problem, where they are, and then interventions that would impact specific factors that predict an outcome. In that case would be the quality of the diet. So we're putting together, this is not real numbers, but dashboards where you could actually track down as you push interventions, as you implement intervention over years. Okay, I've intervened in this neighborhood where the food supply was of low quality. There are new gardens that are put together by the city, by the communities, and so on. And you can look at how people start consuming more fruits and vegetables over time. You have different ways of presenting that according to socioeconomic status, whatever. So this is where we're going. And this is not in 10 years. This is right now. How can we measure the impact of our interventions We need to measure what people are doing, how they behave. We have to characterize their environment. And therefore, we can put all these data together and start making sense of the complex relationship between behavior and food and health. So, of course, this is the built environment, but you can also look at the social environment. So now you can use artificial intelligence to analyze what people are exposed to socially. And for example, you can analyze the tweets related to diet. These are data from the US. We don't have data like this very much for Canada yet, but we're working on this. So you can actually look at, of all the tweets that were related to food, what was the proportion that had a mention of fast food in it? So you can use the unstructured data, artificial intelligence, all put that together into algorithms and then map out states, in that case, where the proportion of fast food tweets are higher than the proportion of fast food tweets in other states. And then, of course, this is not a causal relationship, but this shows that there are trends in some states talking more about fast food than other states. And for sure, socially, this has to have an impact on how people behave. So we can actually do that, and there are exciting new research to be done in this area, looking at Facebook, exposure, tweet exposure, and so on, and interconnect all this with the food environment, with the behaviors, and so on. So this is quite exciting, and this is doable right away. We can do that. And you can actually relate these data. For example, the higher the proportion of tweets that contain the mention of fast food or calories, that correlates with obesity and with the prevalence of hypertension. So these are not causal relationships, but directly you can see associations, and we need to consider that when we look at the effect of diet on health. These are very complex interactions. So we have to move away from that. So we've been using the food diaries for many years. It's tedious, it's costly, it's hard to interpret, etc., etc. So I think it's time now to develop these new approaches, and they're ready to go. We can do that. As I mentioned, we have a project that we're starting to look at the diet of the Quebec population as it changes over time with policy changes. And this is a very exciting time where we are moving away from the more traditional approach to the study of diet and health to more technical, technology-based approach. And we have, this is a cartoon that was published in Quebec when the Canada's Food Guide came out. And so the idea here, of course, is to be able to measure the impact of these policies. Are we changing the lives of people, the way they eat, using a new policy? And to do that, we have to be in a position to measure, analyze, and use all of the data that's available. And I think this is a very exciting time because we don't traditionally have strong data in Canada, but now we have the capacity to do that. And I've described to you a few of our initiatives, but there are many others that are being put together in Canada. And I think in the next 2, 3, 5 years, we'll be able to position ourselves as leaders in this area and be part of those graphs that are published in the Lancet and say, well, here's Canada. You know, we don't have those data in Canada, so it's really interesting. So this is the people who do all the work in my group. So thank you very much for your attention, and I look forward to questions.
Thank you very much, Benoit. Can I take chair's privilege and ask a question? So reflecting on that...
No, you can't.
Reflecting on that table of disruptive technologies. So what you've described is available now, like you're doing it right now. But can you imagine what would make your job easier if it's further out on that spectrum of a technology that you could envision as being something that you would say would improve the quality of the data that you're using right now?
Yeah. Well, you've talked, I mean, we can think out of the box completely, and you've talked about the intelligent toilet, whatever, you know, something like that, where you could actually, like for the metabolomics approach, you could have data that are being analyzed in real time when the toilet takes a sample of your skin, for example, and can measure on site, actually, can track what your diet is. And I think that's kind of crazy, but that's not so far away. And I mean, in 20 years from in the last 20 years, we were not able to measure the genome of a person. And now we can do that in 1 hour, you know. So these approaches, the metabolomic approaches, and how we can measure the profiles that relate to different dietary aspects, that's not doable in a large scale right now. That's going to become available very quickly. So I would assume in the next 5 years we'll be able to do that like this and have profiles. So that would make our lives much easier, because then we wouldn't have to rely on self-report data, which is a big problem, of course, in our area.
And we'll save that for the panel, but certainly the dietary assessment piece and dietary recall would certainly be an area for
Sure.
thinking about how we can
Yeah.
capture.
But this will always rely on self-report until people start taking pictures, and I know some applications are being developed for that, but there are some also challenges in that area, whereas the profile is just an objective measure. So, well, we can talk about this at the question period.
Okay, well, thank you very much, Benoit.